Hello friends, so in today's question, in figure, mass small m is being pulled on an incline of a wedge of mass capital M. All surfaces are smooth. Find the acceleration of the wedge. So this is inclined plane, inclined wedge of mass capital M. This is its incline on which a small mass m is being pulled, and this angle is given as theta. And we have to find out acceleration of the wedge. Okay. So first of all, let us say that the acceleration of the block with respect to wedge. Okay. Say that let the acceleration of the block of mass m relative to wedge of mass capital M, and this will be given as a small m and capital M, and we say let this will be equal to a. And similarly we find out for wedge with respect to ground. Okay. And acceleration of wedge of mass capital M relative to ground is given as AMG, and let us call it as capital A. So because of the relative motion, we can write the equation of relative with respect to acceleration. We can say that equation of relative motion for mass small m, and this will be given as AMM is equal to AM with respect to ground minus AM capital M rather with respect to ground. From here we can find out that AMG will be equal to AMM plus AMG. Now we can find out, or we can simply write this as, the simplest way this can be written as AM is equal to AM capital M and plus A capital M. Okay, we simply remove the G. Now in this case we say that this block capital M is moving towards left. Okay, you can write here towards left. So its motion is in this direction, and it is moving with the acceleration of capital A. And this with small a is moving down the inclined plane with the acceleration A. So we can draw these two figures here with respect to acceleration only without showing the details about the masses. You can say that this is the acceleration A and this is small acceleration A of mass small m and capital M. So this acceleration A can be divided into two components. Okay. This angle is given as theta. This angle is given as theta. Okay. So we can say that this will be our theta, and we are going to have this component as a cos of theta, and this will be having as a sin of theta. So based on that, we can find out the acceleration of block small m in x direction. Okay, you can say that acceleration of mass m in, okay, now the x direction we are taking like this. This is our y and this is our x. In x direction will be given as am in x direction is equal to, we have in x direction of acceleration of small a and minus a cos of theta. Sorry, I drew it wrong. This is our x and this is our y. My apologies for that. I drew it wrong. Okay. X and y. So we get this as, so acceleration A in this direction, so net acceleration will be A minus A cos of theta, and acceleration in y direction acceleration of mass m in y direction will be given as am y will be equal to a sin theta. This is the respect to acceleration. And next, find out the various forces, normals, etc., which are acting on block capital M as well as small m. So for capital M, first of all there will be a mg, capital Mg, acting downward direction, and we have acceleration A in this direction. There will be normal acting because of the surface of the contact of, it is in contact with the surface. So there will be normal acting in upward direction. Let us call that N1. And there will be also normal loss of, because of the mass small m, and it will be acting like this. Let us call this as N2, and this angle is given as theta. So let us divide this N2 into component form. This will be theta. Okay. So we get n cos of theta and n sine of theta, and I think these are all the forces, yeah, and this is x and this is taken as y. So now we find out the sum for the, you can say, for block, for wedge of mass capital M, summation in x direction of all the forces will be 0, summation of f of x giving us n sine theta, and that will be equal to ma, acceleration in this direction will be equal to ma, and sorry, this is n2, yeah, this is n2. So from here we can find out our n2, that n2 will be equal to ma divided by sine of theta. Let us call this equation number 1. And summation in y will be giving us, we have n1 minus n2 cos of theta, and there will be minus mg is equal to 0. And let us call this equation number 2. Next we draw for small mass for block of mass small m. So this is a small block, and it is going to have mg downward direction, okay, and because of the capital block we have n2 in this direction, so, and this mg can be divided into two parts, rather two components, and this will be our theta. So we can say that this is mg sine of theta, and this will be mg cos of theta, yeah. So this will be our x and this will be our y. So summation fx will be giving us, yeah, one more thing, there is a force also acting in this direction. We have a force here and acceleration in this direction. So we have F plus mg sine theta, and that will be equal to we have m, and in that direction we will have a x component of the velocity, okay, and we already know the x component of the velocity of ax, okay. So we can expand this equation as f plus mg sine theta is equal to m, putting the value of x component, that is a minus a cos of theta, and that is equation number 3. And for y component we have mg cos of theta minus, and we have this n2, and this will be giving us ma y, and we already know value of y component for block M. So we can extend this as mg cos of theta minus n2 is going to give us ma sine of theta, and let us call this as equation number 4. So we already know value of n2. Okay, we substitute value of n2 from equation 1 in equation 4. For using equation 1 in equation 4, we get mg cos of theta minus, and n2 was ma sine of theta is equal to ma sine of theta. This can be further solved as mg cos of theta is equal to, taking a as common, we get this as m sine of theta plus capital M sine of theta. This can be further written as, taking as sine theta as LCM, you can say that m sine square theta plus capital M divided by sine of theta. From here you can say that A will be equal to mg cos of theta multiplied by sine of theta and divided by m sine square theta plus capital M. Okay. This is the acceleration of the wedge. Okay. Acceleration of the wedge of mass capital M. Thank you.